Hello, in the video now we're going to look at the difference between mass and weight, something that people do get confused with. So as a reminder, weight equals mass times gravitational field strength. So some people might call the object that you can see a weight, but others may call it a mass. Mass is the amount of matter or substance that makes up an object, the amount of stuff. Weight is the force that you feel due to the gravitational field strength on the mass. So let's use the equation as an example. Let's say that the mass is 10 kilograms. The value of gravitational field strength on Earth is 9.8, so its weight when we pick it up would be 98 newtons. That's the force we would need to apply to lift it up. Let's imagine we can now move the mass onto the moon. The object's mass remains the same. The amount of stuff or matter is still 10 kilograms. However, the moon has a sixth of the size of the gravitational field strength. So therefore, it will be easier to pick the mass up. That's because on the moon, 10 times 1.6 gives us a weight or a force required to lift it up of 16 newtons. So that's a lot easier than the 98 on Earth. Let's go to a different place in the solar system. Let's try Jupiter. So, like before, the mass still has a mass of 10 kilograms. But because Jupiter is so much larger than Earth, the value of the gravitational field strength is bigger too, which is 25 newtons per kilogram. So therefore, to lift up that same mass on Jupiter, you would require 250 newtons. One way to remember it, if you spell out the word mass, mass always stays the same. No matter where you are, mass remains constant. The weight, however, can change, and it depends on how strong the gravitational field strength is. Therefore, we would say that the weight of an object and the mass of an object are directly proportional to each other. If one goes up, the other one goes up too. So if we were to draw a graph of this with weight on the y-axis, mass on the x-axis, it would be a straight line through the origin. Weight and mass are directly proportional. One way of measuring weight is by using a calibrated spring balance, also known as a Newton meter or a force meter. This topic then also links a little bit to Hooke's law, where force equals spring constant multiplied by the extension of the spring. Hope you found that useful, and as ever, if you have, please remember to press the subscribe button.